Hello, good evening. Good evening.
How are you, sir?
Very fine, very fine. How are you?
Yeah, doing great, sir. Thank you very much, sir.
Yeah. It's a wonderful time. Again, the opportunity for us to interact once again.
Thank you, sir. Thank you, sir. And thank you for accepting our invitation to deliver this time also, sir.
That is the honor for us all the time.
Yes, sir.
Yeah.
Sir, shall we wait for another 5 minutes?
No problem. No problem. Absolutely no problem.
Okay, sir. Thank you, sir.
ಸರ್ ಆಮೇಲೆ ಇನ್ನೊಂದೇನಂದ್ರೆ ಇವತ್ತಿನ ಒಂದು ನೀವು ಕೊಡ್ತಾ ಇರ್ತಕ್ಕಂಥ ಆಸಿಡ್ ಬೇಸ್ ಟಾಪಿಕ್ ಮೇಲೆ ಸರ್
ಹಾ
ಸೊ ಸ್ಟೂಡೆಂಟ್ಸ್ ಗಳಿಗೆ ಸ್ವಲ್ಪ ಈ ನೀಟ್ ಎಕ್ಸಾಮ್ಗೆ ಮತ್ತೆ JEE ಮತ್ತೆ ನಮ್ಮ CET ಎಕ್ಸಾಮ್ಗಳಿಗೆ
ಓಕೆ
ಈ ಒಂದು ಟಾಪಿಕ್ ಮೇಲೆ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಬರುತ್ತೆ ನೀವು ಯಾವ ತರ ಪ್ರಿಪೇರ್ ಆಗ್ಬೋದು ಅನ್ನೋದನ್ನ ನಿಮ್ಮ ಒಂದು ಇದರಲ್ಲಿ ಸ್ವಲ್ಪ ಲಿಟಲ್ ಬಿಟ್ ಆಗಿ ಸ್ವಲ್ಪ ಇದು ಮಾಡಿ
ಆಯ್ತು ಆಯ್ತು ಓಕೆ 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 ದಟ್ಸ್
ಅದನ್ನ ಕಾನ್ಸಂಟ್ರೇಟ್ ಮಾಡಿ ಯಾಕಂದ್ರೆ ನಮ್ಮ ರಮೇಶ್ ಸರ್ ಹೇಳ್ತಾ ಇದ್ರು
ಹಾ 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 ಓಕೆ
ಸ್ವಲ್ಪ ಬೇರೆ ಇದ್ರಲ್ಲಿ ಬಿಸಿ ಆಗಿದ್ದಾರೆ ಇವತ್ತು ಆಕ್ಚುಲಿ ಕಂಡಕ್ಟ್ ಮಾಡಕ್ ಮಾಡಿದ್ರು
ಹಾ 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 ಬಟ್ ಈಗ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್ ವಿಲ್ ಬಿ ಅವರು ಸಹ JEE ಮೇನ್ ಪ್ರಿಪೇರ್ ಮಾಡೋದಿರ್ತಾರೆ ಅಲ್ಲಿ
ಎಸ್ ಸರ್ ಅದಕ್ಕೋಸ್ಕರ ಯಾಕೆಂದ್ರೆ ಅವ್ರಿಗೆ ಈ ಸಾರಿ ನಾವು ನೋಟ್ಸ್ ಬೇರೆ ತರ ಮಾಡಿಸ್ತಾ ಇದೀವಿ ಅವ್ರಿಗೆ JEE ನೀಟು ಮತ್ತೆ CET ಎಕ್ಸಾಮ್ಗಳಿಗೆ ಅವ್ರಿಗೆ ಯಾವ ತರ ಕ್ವಶನ್ಸ್ ಮಾಡೆಲ್ ಟೈಪ್ ಬಿಡ್ತಾ ಇದಾರೋ
ಆಯ್ತಾ ಹಾ
ಬಟ್ ಪ್ರೆಸೆಂಟ್ ಸಿಲೆಬಸ್ ಮೇಲೆ ನಾವು PCMB ಅವ್ 4 ಮೇಲೆ ಸರ್ ಕ್ವಶನ್ ಬ್ಯಾಂಕ್ ಮಾಡ್ತಾ ಇದೀವಿ ಸರ್ ಈ ಸಾರಿ
Oh, that is something great. Something.
Before November, we sent through all the students, sir.
Oh, that's good. That is good. Good.
That's why, sir, please concentrate to NEET and JEE exam.
Okay. JEE also. Okay. Sorry.
Okay, sir.
Yes.
Another 2 minutes, sir.
No problem. Take your own time.
Okay, sir.
Yeah.
ವಿದ್ಯಾರ್ಥಿಗಳೇ ಇವತ್ತಿನ ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮದಲ್ಲಿ ನೀವು ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ಹಾಜರಾಗಬೇಕು ಎಂದು ಮತ್ತೊಮ್ಮೆ ತಮ್ಮೆಲ್ಲರಿಗೂ ತಿಳಿಸುತ್ತಾ ಇವತ್ತು ನಮ್ಮ ಮಾನ್ಯ ಸಚಿವರು ಕೂಡ ಇವತ್ತು ನಮ್ಮ CEO ಸರ್ ಜೊತೆ ಮತ್ತೆ ನಮ್ಮ MD ಸರ್ ಜೊತೆ ಈ ಒಂದು ಪ್ರತಿಭಾಸ್ವಾದ ಯೋಜನೆ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡಿ ಒಂದು ಚರ್ಚೆ ಮಾಡಿ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮ ಇನ್ನು ಎಲ್ಲಾ ನಮ್ಮ ರಾಜ್ಯದ ಎಲ್ಲಾ ಮೂಲೆಗಳಿಗೂ ತಲುಪುವ ಒಂದು ರೀತಿಯಲ್ಲಿ ಇವಾಗ ನಾವು ಡಿಸ್ಟ್ರಿಕ್ಟ್ ಅಲ್ಲಿ 10 ಜನಕ್ಕೆ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದ್ವಿ ಸೊ ಅದ್ರ ಜೊತೆಗೆ ಇನ್ನು 20 ಜನ ಎಕ್ಸ್ಟ್ರಾ ಸೆಲೆಕ್ಟ್ ಮಾಡಿ ಈ ಕಾರ್ಯಕ್ರಮನ ಒಂದು ಮುನ್ನೆಲೆಯತ್ತ ತಗೊಂಡೋಗ್ಬೇಕು ಅಂತ ಸಚಿವರು ಕೂಡ ಇವತ್ತು ನಮ್ಮ ಜೊತೆ ಡಿಸ್ಕಸ್ ಮಾಡೋದ್ರಿಂದ ತಾವುಗಳು ಪ್ರತಿದಿನ ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ಹಾಜರಾಗಿ ಈ ಒಂದು ಉಪನ್ಯಾಸ ಕಾರ್ಯಕ್ರಮವನ್ನು ತಪ್ಪದೆ ಕೇಳಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ನಮ್ಮ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ತಿಳಿಸುತ್ತಿದ್ದೇವೆ.
Shall we start, sir? By the time I finish introduction.
ಶುರು ಮಾಡಿ ಸರ್ ಉಮೇಶ್ ಸರ್.
Very good evening to one and all. ಎಲ್ಲರಿಗೂ ಶುಭ ಸಂಜೆ. I welcome today Dr. Ronald Nazareth sir, and all the students and teachers who have joined with us in this today's platform and WebEx platform, as well as in the YouTube channel. Few of the students who have joined in the YouTube channel also. I welcome you, all of you, once again to this Talent Search Program webinar series. Today we have with us Dr. Ronald Nazareth sir. Before starting today's session, I would like to give brief introduction about Dr. Ronald Nazareth sir. First of all, I would like to thank them for accepting our invitation to deliver today's session. Thank you very much, sir.
Thank you. Thank you.
So before starting the session, I just want to give a brief introduction about Nazareth sir. Sir has finished his PhD in the chemistry from Bangalore University and MSc from St. Joseph College, Bangalore, and BSc from Purna Pradnya College, Udupi, PUC from St. Mary's College, Shirwa, and early education in St. Johnson Institution, Shakerpura. Sir has joined St. Aloysius College as a lecturer in chemistry in the year of 1993. At present, he is working as an associate professor and head of the Department of Undergraduate and Postgraduate Studies and Research in Chemistry, with teaching experience of over 26 years for UG and 11 years for PG students. He was the Students Welfare Officer, Student Counselor for undergraduate and postgraduate students, and he was the coordinator for Astitwa, a national collegiate level cultural festival at St. Aloysius College, and coordinator for the national seminars and intercollegiate chemistry programs held for the students for pre-university and UG and PG level students. He was the associate NCC officer of NCC Air Wing for 15 years and was the contingent commander for Karnataka and Goa contingency for All India Vayu Sainik Camp held at Hyderabad. At present, he is the coordinator of Star College scheme of St. Aloysius College, a scheme by Department of Biotechnology, Government of India, and represented the college every year in the expert committee meetings held in New Delhi. This scheme is upgraded to star status now, and St. Aloysius College is now one among the 2 colleges in India getting this status. And he is also in the advisory committee for the activities of Star College scheme in SCSS College, Bantwal, and STM College, Ujire. He is research supervisor for PhD under Bangalore University. Currently, 5 students are working for PhD under his guidance. He has published many research papers of many reputed national and international journals. Presently working on minor research project on synthesis of functionalized nanoparticles and its application to inhibition of corrosion of maraging steel by UGC with research grant of 4.9 lakhs. Indian examiner for the PhD waiver examination at Bharatiyar University, Coimbatore, and Bharati Darshan University, Coimbatore. He is resource person for many seminars in chemistry for college teachers and students of PUC graduate and postgraduate level. Also, he is a resource person for the PU chemistry lecturers of DK, Dakshina Kannada, Udupi, Hassan, Chikmagalur districts on techniques in chemistry teaching at the pre-university level. Apart from that, he is the resource person on ICT in chemistry at the pre-university level. He was the management representative for the Assembly of International Association of Jesuit Universities held at Deusto University, Biblios, Spain in the year of 2018. Also, he was the member of management team to Portugal for signing MOU with the universities from Lisbon, Porto, and Villarreal of Portugal. He has authored many textbooks for the chemistry students of Karnataka, pre-university level, and books for chemistry competitive exams like NEET, JEE, and CET. With this brief introduction, I would like to welcome you once again, sir. Over
Thank
to
you.
you, sir.
Thank you. Thank you for this generous introduction. I'm extremely happy to be a part of this particular activity of the KSTA, wherein the lot of initiatives are taken. Maybe sometime we don't see the required performance by the students, mainly because we have failed to inspire them. We have failed to reach to them. We have probably failed to communicate to them such a way that what are the methodology of learning, Patasai? And this organization is doing extremely good job in that way, wherein they reach to the student, they will be inspiring the students, and so that those of students who want to study, they will get the avenues, the methodology, as well as the content. Therefore, at the outset, on behalf of the whole community of the student, I should congratulate and thank the team which is organizing this KSTA team, which is organizing this and this wonderful innovative approach in which they have. ಯಾವಾಗಲೂ ನಾವು ಈಗ ಆಸಿಡ್ಸ್ ಬೇಸ್ ಇರಲಿ ಯಾವುದೇ ಸಬ್ಜೆಕ್ಟ್ ಇರಲಿ ಸ್ಟೂಡೆಂಟ್ಸ್ನೊಟ್ಟಿಗೆ ಇಂಟರಾಕ್ಟ್ ಮಾಡೋದು ಇಸ್ ಎ ಪ್ಲೆಜರ್. And very happy moment for any teacher is interacting with the student, getting their doubts, and sometimes the doubts which is truly that talks about the creativity of the student. And therefore, this curiosity driven drive of our students whenever they are into, I'm sure it is successful. ಅದರಿಂದ ಯಾವುದೇ ಟಾಪಿಕ್ಸ್ ಅನ್ನು ನಾವು ಇಲ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡುವಾಗ ಅದರಲ್ಲಿ ಬರುವ ತುಂಬಾ ಕ್ವೆಶ್ಚನ್ಸ್ಗಳಿರ್ತವೆ. ವಿ ಹ್ಯಾವ್ ಟು ಹ್ಯಾವ್ ದಟ್ ಕ್ವೆಶ್ಚನ್. ಯಾವಾಗ ನಾವು ಕ್ವೆಶ್ಚನ್ಸ್ ಮಾಡಬೇಕು, ಯಾಕೆ ಹಾಗೆ, ವೈ ನಾಟ್ ದಿಸ್, ಇಫ್ ಐ ಚೇಂಜ್ ದಿಸ್ ಒನ್ ಟು ಹಿಯರ್ ವಾಟ್ ವಿಲ್ ಹ್ಯಾಪನ್. See, all those things, questions when they come, it is the best forum for you to interact and find out all curiosity driven questions in that regard. Therefore, I'm extremely happy to be a part of it. Therefore, let us see how exactly this acids base, amla pratyamla ಏನು ಹೇಳ್ತಾ ಇದ್ದೇವೆ ನಾನು. ಸೊ ಅದ್ರ ಬಗ್ಗೆ ಏನು ಪ್ರಯೋಜನ, what exactly are they, and what are the ways in which some competitive examination we are asked with the questions. All these things we'll look into a quick remarks. So we are into acids and bases. Whenever we say acids and bases, we say these are the substances which are present in it. Everywhere they are present. At home, if you go home quickly and find out, there are so many compounds, they are acids and bases. Maybe the vinegar which you are talking about is acid, or the citric acid, citrus fruit which you are talking about contain acids which are present there. This bleaching you are talking about contains plenty of bases. So what is the bleaching? ಬಟ್ಟೆಗಳಿಗೆ ಒಂದೊಂದು ಕಲೆ ಆದಾಗ ನಾವು ಹಾಕ್ತೇವಲ್ಲ some chemicals which is having a typical chlorine smell. That is prepared by taking a base, sodium hydroxide base, and passing chlorine to it. Now soap ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೇವಲ್ಲ, soap solution ತುಂಬಾ ನೊರೆ ಬರ್ತದಲ್ಲ ಅದರಲ್ಲಿ. Whenever there is some froth which is coming, that are the bases. Therefore, these acids and bases are everywhere. Every aspect of our life we come across these acids and bases, and which is there in our food. Maybe the citrus fruit I is referring is to. ನಿಮಗೆ cold drinks ನಾವು ಕುಡಿತಾ ಇದ್ದೇವಲ್ಲ, that cold drinks has a typical acid in it. There is a name for the acid. That acid is obtained by passing carbon dioxide through water. Carbon dioxide plus water, that acid which is given, we call carbonic acid. That is an acid compound, acidic compound. Forget about all those things. Whenever we take food, the food will go to our stomach, and in that stomach, in order to have a proper breakdown of that food into smaller component, the medium should be acidic, and that exists hydrochloric acid. Sometimes hydrochloric acid, in case if the concentration of hydrochloric acid in the stomach increases, we call that concept acidity. Suddenly we take some bases. ಯಾವ ಬೇಸ್ ತಗೊಳ್ತೀರಾ? ಆಂಟಾಸಿಡ್ ಆಗಿ ತಗೊಳ್ಳುವ, ಜನರಲಿ ತಗೊಳ್ಳುವ ಬೇಸ್ ಯಾವುದು? We take bases like ಯಾವ ಬೇಸ್ ತಗೊಳ್ತೀರಾ? ಅಲ್ಯೂಮಿನಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅಥವಾ ಮೆಗ್ನೀಷಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್. These are the present in antacids. they are the one which will go to our stomach and neutralize that hydrochloric acid which is present there. So these are the acid-base chemistry is a well-known chemistry in food, maybe in a house I was referring so many chemicals there. Therefore, even we contain in us. Now see, ಒಂದು ವೇಳೆ sometime whenever we take acids which are having in our stomach, if the acidic nature increases drastically, food won't get digested. Therefore, if that food digestion, proper digestion of the food take place in the intestine and get absorbed into the body, and there it should be slightly basic. By chance, ಅಲ್ಲಿ ಸಹ ನಮಗೆ ಆಸಿಡ್ ಆಗಿಯೇ ಇದ್ರೆ digestion won't take place. Absorption of food inside the body doesn't take place. Therefore, within us, it is a system which is in the stomach, acidic. When you go to intestinal juices, a moderate beyond 7 pH, what you refer it to, that will occur there. Therefore, these are some of the acids and bases. ಬೇಕಾದ್ರೆ ಕೊಂಡ್ರೆ ವಿನೆಗಾರ್, ಲೈಮ್ ಜ್ಯೂಸ್, ನಮ್ಮಲ್ಲಿ ಮನೇಲಿ ಬ್ಯಾಟ್ರಿ ಇರ್ತದಲ್ಲ, ಇನ್ವರ್ಟರ್ ಬ್ಯಾಟ್ರಿ ಉಂಟಲ್ಲ, ಅದರಲ್ಲಿ ಒಂದು ಆಸಿಡ್ ಉಂಟು. ಯಾವ ಆಸಿಡ್ ಅದು? I'm sure that everybody knows. Is a sulfuric acid. 38% sulfuric acid is there. ಆ 38% ಮೇಂಟೈನ್ ಮಾಡಬೇಕಾದ್ರೆ we keep on adding water. ಸ್ವಲ್ಪ ವಾಟರ್ ಲೆವೆಲ್ ಕಡಿಮೆ ಆಯ್ತಾ ಅಂತ ಚೆಕ್ ಮಾಡ್ತಿರ್ತೇವೆ ನಾವು. Therefore, that contain acid. Even soda water contain acid. As I was mentioning about it, soap contains the bases and so on. Therefore, the acid bases, in simple terminology, acid should have a pH less than 7. So we find out the strength of the acid in terms of pH. Therefore, if the pH of the solution is less than 7, we call it is acid. If the pH of the solution is more than 7, we call it is a base. Therefore, acid base anta helbekadre pH should be 7 athava more than 7 that should be known to us. So a few acids like, for example, tartaric acid, which is present in tamarind, or these ants contain formic acid. Formic acid is very corrosive chemical. If at all there are some projections in your face or you see sometime, they add formic acid to remove them. That is present in red ants, the formic acid which is present. And similarly, if you say some of the acids, like the acid which is mentioned there, aspirin. What is aspirin? Acetyl salicylic acid is called aspirin. I repeat once again, this is a question asked for some of the competitive examination. Aspirin. Heard about aspirin? Which is an antipyretic and analgesic drug. What is antipyretic means? Antipyretic means which reduces the body temperature. If a chemical reduces the body temperature, I call them antipyretic. This is the chemical. Aspirin is that chemical which reduces the body temperature. It is also analgesic. What is analgesic means? A chemical or the medicine which reduces the body pain is called analgesic. Therefore, aspirin is found to be both antipyretic as well as analgesic. Then you coming to one more example like amino acids. An amino acid is a building blocks of protein. ನಮ್ಮಲ್ಲಿ ಪ್ರೋಟೀನ್ ಇದ್ರೆ ಅದನ್ನು ಯಾವುದರಿಂದ ಮಾಡಲ್ಪಡ್ತವೆ ಪ್ರೋಟೀನ್ಗಳು? ಅಮೈನೋ ಆಸಿಡ್ ಇಂದ. ಅದರಿಂದ ಅಮೈನೋ ಆಸಿಡ್ ಅಲ್ಲಿ ಅಮೈನೋ ಗ್ರೂಪ್ ಇರಬೇಕು. ಅಮೈನೋ ಗ್ರೂಪ್ is derived from ammonia. Therefore, it is a base. Acid group is from the carboxylic acid which is present there. Therefore, amino acid contain both acid as well as base component in it. Therefore, we call the amino acid, since they contain an H2 group which is basic in nature, and the COOH group which is acidic in nature. They have both acidic and basic in nature. We call it their amphoteric in substance. Caffeine, we say sometime, so lot of enthusiasm to get, we drink little tea, and that tea contains caffeine. It is a very good stimulant. It is a very weak base. Now we should know, base anta helbekadre generally it should derive from ammonia. The compounds which are derived from ammonia contain bases. You'll ನೋಡಬಹುದಲ್ಲ caffeine ಅಲ್ಲಿ caffeine structure ನೋಡಿ, ಅದರಲ್ಲಿ ನಿಮಗೆ ನೈಟ್ರೋಜನ್ ಕಂಪೌಂಡ್, Nitrogen contains a lone pair of electrons. So many nitrogen, 1, 2, 3, 4 nitrogens are visible there. All these 4 nitrogen contains lone pair of electron present in. If a substance is giving that lone pair, we will see sometime later. If substance gives that lone pair, we call them the base. Therefore, caffeine contains so many nitrogen atoms capable of giving the lone pair of electron. A substance which gives the lone pair of electron, we call them bases. Like for example, you see the acid which is present there, sulfuric acid. Sulfuric acid, some of the in the small insect which has this flux, they will give out the sulfuric acid for the self-defense. The moment sulfuric acid will drops on the hand, it burns. Or in case if it is flushes to the eyes, it will burn. And therefore, it is escaping. So that it is a mechanism for the self-defense, some of the chemicals which are there. There are the acids and bases which are mentioned. So that now the question comes, what is acid? Oldest definition came from Arrhenius, which says that if there is a H plus ion, if a solution gives H plus ion in water, when added to water, that is said to be acid. The substance ಅನ್ನು acid ಅಂತ ಹೇಳಬೇಕಾದ್ರೆ ಅದು ನೀರಿಗೆ ಹಾಕಬೇಕು. ಯಾರು ಹೇಳಿದನು? Arrhenius says. If it is added to water and then it is acid. And before this theory came, people started differentiating acids and bases. Like a substance which is sour in taste, maybe corrosive, which is there. In case if there is a fabric, that corrosion occurs on the fabric, the strongly the acid, they reacted with the metal liberating hydrogen, or a substance which on adding on the litmus paper, which will turn the blue litmus paper red. We call them acids. These are all the general idea. There are some acids. See, the acid to call, then you talk about the relative strength of the acid. All acids will not liberate hydrogen when added to a metal, or rather all metal will not be in a position to liberate hydrogen. You know, even strongest of the strong acid like sulfuric acid cannot react with copper to liberate hydrogen. Therefore, these are the ideas which we are told in the primitive stage, very beginning stage. What exactly acid? A substance which is sour in taste, it is corrosive, they react with metal to liberate hydrogen. So these are the initial stage. Then we found out that all acids will not liberate hydrogen on adding it to a metal. So therefore, acids are the substances like vinegar, citric acid, the source. That vinegar contain acetic acid, lemons, oranges contain citric acid, vitamin C contain ascorbic acid. Vitamin C is ascorbic acid, which is present plenty in gooseberries, which also is present in the lemons, which contain vitamin C. Sulfuric acid is used for the production of fertilizers, maybe the paints, the steel, plastic, and so on. The batteries which are there in the inverter contain acids like sulfuric acid, inverter batteries, car batteries. They're the same one, the lead storage battery contain the acids there. And therefore, these are some of the compounds containing citric acid and this ascorbic acid and so on. Now, a base is the earlier stage. I'm saying without going for the definitions proper, a substance contains lot of OH minus ion. It is a base, in other word, for the base is called alkali. So, amla pratyamla, alkaline solution. That means it's a basic solution. So, they can accept hydrogen ion, we call them bases. And you know very well, ಒಂದು ಆಸಿಡ್ ಕೈಗೆ ಬಿದ್ದರೆ ವಾಶ್ ಮಾಡಿದ್ರೆ ಹೋಗ್ತದೆ, ಬೇಸ್ ಹೋಗುದಿಲ್ಲ ಸುಲಭದಲ್ಲಿ. ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಡ್ರಾಪ್ ಕೈಗೆ ಹಾಕಿದ್ರೆ ಸುಲಭದಲ್ಲಿ ಹೋಗುದಿಲ್ಲ, ದಟ್ ಇಟ್ ಬಿಕಮ್ ದ ಸ್ಲಿಪರಿ ಅಂಡ್ ದೇ ಟೇಸ್ಟ್ ಬೆಟರ್. ದೇ ಆಲ್ಸೋ ಆರ್ ಕೊರೂಸಿವ್, ದೇ ಡೋಂಟ್ ರಿಯಾಕ್ಟ್ ಟು ದ ಮೆಟಲ್. ಇದೆಲ್ಲ ಇನಿಷಿಯಲ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಡಸಂಟ್ ಮೀನ್ ದಟ್ sodium hydroxide never react to the metal. There are some metals with sodium hydroxide react. Can you identify some metals? We call them, these are amphoteric metals. There are some metals. This is the previous idea. Preliminary idea is base do not react to the metal. But now we know metals like zinc, then lead, then tin, then aluminium, antimony. All these metals, we term them are the metals present close to the P block. They are the metals which are readily reacting with a base like sodium hydroxide, liberating hydrogen. ಇದನ್ನು ಕೇಳ್ತಾರೆ ಯಾವಾಗ ನಿಮ್ಮ JEE ಮೇನ್ ಎಕ್ಸಾಮ್ಗೆ ಆಗಲಿ ನಿಮ್ಮ CET ಗೆ ಎಕ್ಸಾಮ್ಗೆ ಆಗಲಿ ಕಾಂಪಿಟೇಟಿವ್ ಎಕ್ಸಾಮ್ಗೆ ಇದನ್ನು ಕೇಳ್ತಾರೆ. Which are those metals react with sodium hydroxide, liberating hydrogen? Generally, metals not supposed to react with sodium hydroxide because a metal should react with acid. If they react with a base, the metal is having amphoteric nature. ಯಾವ್ದದು ಯಾವ ಮೆಟಲ್ಸ್ ಅದು? The metals which are present close to the P block element in the periodic table. ಯಾವ್ದದು ಹತ್ತಿರ ಇರುವಂತದ್ದು? Even beryllium does that. Beryllium P block ನ ಹತ್ತಿರ ಉಂಟು. Therefore it is a base. It shows the nature of the acid. So it reacts with sodium hydroxide. Beryllium ಇರ್ಬೋದು, aluminium, zinc, lead, tin, antimony. ಯಾವ್ದೆಲ್ಲ ಹೇಳಿದ್ರೆ ನಾನು very important. ಇದು ಯಾವಾಗಲೂ ಕೇಳುವಂಥದ್ದು. Chemic metal which react or metal chloride, metal hydroxide reacting with sodium hydroxide. 5-6 metals are there which are present very close to the P block element, and they are the one which are having the nature, of amphoteric nature ಅಂತ ಹೇಳ್ತೇವೆ. ಎಂತ amphoteric nature ಅಂದ್ರೆ they react with acid ಆಗ್ತದೆ, ಅದು ಬೇಸ್ ದೊಟ್ಟಿಗೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತದೆ. These metals which are, what preliminary idea? They should not react with the base. Then so bases should not react with the metal. That is what the preliminary idea is all about that. Okay. Then therefore where are we come across? Soap preparation. ನಿಮಗೆ soap ಹೇಗೆ prepare ಮಾಡೋದು ಗೊತ್ತುಂಟಾ? ಮನೆಯಲ್ಲೇ prepare ಮಾಡಬಹುದು soap ಅನ್ನು. There are good number of industry which say we can prepare soap at home. With that ಏನ್ ಮಾಡಬೇಕು? ಆಯಿಲ್ ತಗೊಳ್ಬೇಕು. ಯಾವುದು ಆಯಿಲ್? ಮೇಬಿ ಕೋಕೋನಟ್ ಆಯಿಲ್, ಸನ್ಫ್ಲವರ್ ಆಯಿಲ್ ತಗೊಳ್ಬೇಕು. ಅದಕ್ಕೆ ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಹಾಕ್ಬೇಕು ಮತ್ತೆ ಬಿಸಿ ಮಾಡ್ಬೇಕು ಅಷ್ಟೇ. ಒಂದು ಸೋಡಿಯಂ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಅನ್ನು ಆಯಿಲ್ಗೆ ಹಾಕಿ ಬಿಸಿ ಮಾಡುವಾಗ ಆಯಿಲ್ ಕಂಟೇನ್ಸ್ ದ ಎಸ್ಟರ್ಸ್ ಆಫ್ ಆಸಿಡ್ಸ್. ಆಯಿಲ್ ಕಂಟೇನ್ಸ್ ಎಸ್ಟರ್ಸ್ ಆಫ್ ದ ಆಸಿಡ್. ಎಸ್ಟರ್ಸ್ ಆಫ್ maybe lauric acid, maybe myristic acid, palmitic acid or stearic acid. These acids are esterified and they are present. Now, if you add sodium hydroxide, you will get salt of these acids. Sodium salt of stearic acid, sodium stearate, sodium salt of linoleic acid, sodium linoleate, sodium salt of myristic acid, sodium myristate. This sodium salt of the acid, they are called soaps. And therefore, this soap preparation is even ammonia. Ammonia is used as a cleansing agent there. The OH minus interacts strongly with certain like substances like dirt or the grease. Easily they can be removed out. That's why the sodium salt of fatty acid uses the soap there. Chalk or the calcium carbonate, even the cleaner example, familiar product that contain bases. Chalk is the best example. That is the calcium carbonate, which is a base. Blood is a basic solution. Intestinal juices are the basic solution. Blood is a basic solution because of the bicarbonates which are present there in the blood. So the acid and base ಅಂತ ಹೇಳುವಾಗ now ಇದು acid or base ಅಂತ ನೋಡ್ಬೇಕಾದ್ರೆ I think this table will help you out. Pure water is having a pH of 7. Pure water which will have a pH of 7 there. So it will be pH of 7. This will be a pure. And if it is little less than 7, if the pH is, we call it is the acidic solution. Little lesser than will be the pH 6, which is milk. Little lesser than will be coffee. Vinegar will be having a pH 3. Lemon juice will have pH 2, and we said that hydrochloric acid is present in the stomach, which contain approximately pH 1 or 2, and very strong acid is sulfuric acid, which contain less than 1. When there is highly concentrated solution, then we don't define the pH for this. And going from that, blood contain little more than 7 pH. Then baking soda, Then antacids which are there, which contain magnesium hydroxide, aluminum hydroxide. Pure ammonia solution is having pH 11 to 12. Soap is having sodium salt of fatty acid, sodium hydroxide there. Still, then very high will be the drain and drain cleaners, which in case if there is a block in the drain, which you put, these are very high. Therefore, there are all acids and bases continuously used in day-to-day life. As I was mentioning, we are going for theories of acid bases. A substance which reacts with the water to give H plus or H3O plus said to be acid. Or a substance reacting with water which will give OH minus is a base. Therefore, HCl added to water which will give H3O plus. Therefore, HCl is said to be acid. Whereas ammonia is said to be a base because it will on water, it will give OH minus ion. Therefore, whether it is acid or base depending on whether it gives H plus ion or it gives OH minus ion. Now, the second definition is the Bronsted-Lowry definition. With respect to your competitive examination, this is the most important definition. That is, acid is a proton donor and base is a proton acceptor. Therefore, in case if I say a proton donor, then that is Arrhenius acid is talking about there, which contains nitric acid. Therefore, as when you go to the Bronsted-Lowry in case theory, in case if you talk about, then in the Bronsted-Lowry theory, Bronsted-Lowry theory, we can identify an acid at the base. Now, in the Bronsted-Lowry theory, acid is a substance which will give H plus. Base will take H plus. Therefore, it is possible for us to go and write the molecule here that if the acid will give you CO3 minus 2 and H2O will be taking this water and form their H3O plus. Therefore, acid gave H plus and base took H plus. Same way if you take about HCN there. HCN is acid, therefore it will give H plus and form Cn minus. Water is a base, therefore it took H plus and formed H3O plus. Here, water itself undergoing self-ionization. Water is an acid which gives H plus and H3O plus it takes, another water takes it. Whereas in this case of acetic acid will give H plus, so form acetate ion and H3O plus. Whereas in the case of water reacting with carbonate, CO3 minus 2 should be, so it should give you OH minus and should give you HCO3 minus. HCl and acetic acid, HCl give H plus, so remain with Cl minus, and acetic acid will react to form CH2 plus. Or this is the urea molecule which will give H plus, therefore it will remain with chloride ion and NH2 CONH2 plus. That means all acids give H plus and base take H plus. Therefore, the moment you write an acid-base reaction according to Bronsted-Lowry theory, we can identify a system which differs by a proton. What do you mean by this? This HCO3 and H plus, they differ by a proton. Therefore, in case if I have this CO3 and this one differ by a proton, water and H3O plus differ by a proton, HCN and Cn minus differ by a proton. Therefore, if I have HCN and Cn minus, difference between them by proton. So this is said to be an acid, this is said to be an base. We call this system which differ by a proton is a conjugate acid-base system. So if I give you the conjugate acid, you should tell me the conjugate base for it. If I give you the conjugate base, you should tell the conjugate acid for it. Everywhere, I'm sure you can write the conjugate acid-base pair. Therefore, now you saw some substances like, for example, sulfuric acid is acting as a base, also acting as an acid. You can see a substance, it acts as a base, it also acts as an acid. Urea act as a base, also act as an acid. This type of substances are called amphoteric substances. Amphoteric or amphiprotic substances. Amphoteric or amphiprotic substances are those substances which are acting both as an acid as well as a base. And therefore, this conjugate base, acid-base pair identifying should be possible for us. Now also you should know, stronger the acid, weaker will be its conjugate base. Stronger the acid, weaker will be its conjugate base. This is a very important idea. We will take up some questions which appear for your NEET examination, maybe your JEE main examination, to prove that which are acids stronger and weaker. In order to say an acid is stronger, prove its conjugate base is weaker. ಕೆಲವೊಮ್ಮೆ ನಮಗೆ ಆಸಿಡ್ ಸ್ಟ್ರಾಂಗ್ ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಸುಲಭ ಆಗ್ತದೆ, ಹೇಳಿ ಹಾಗೆ. ಕೆಲವೊಮ್ಮೆ ಅದರ ಕಾಂಜುಗೇಟ್ ಬೇಸ್ ಉಂಟಲ್ಲ ಅದನ್ನು ವೀಕ್ ಅಂತ ಹೇಳೋದು ಸುಲಭ. ಯಾಕಂತ ಸಮ್ ಎಕ್ಸಾಂಪಲ್ ವಿಲ್ ಸಿ. ಸ್ಟ್ರಾಂಗರ್ ದ ಆಸಿಡ್, ವೀಕರ್ ವಿಲ್ ಬಿ ಕಾಂಜುಗೇಟ್ ಬೇಸ್. ಒಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳು. ನಿಮಗೆ ಕೇಳ್ತಾರೆ ಈಗ, ಐ ಆಮ್ ಹ್ಯಾವಿಂಗ್ ದ ಬೈನರಿ ಹೈಡ್ರೈಡ್ ಅಯಾನ್ಸ್ ಆಸ್ ಬ್ರಾನ್ಸ್ಟೆಡ್ ಬೇಸಸ್. ನಿಮಗೆ ಕೇಳ್ತಾ ಇದ್ದೇನೆ ನಾನೀಗ, ಐ ಹ್ಯಾವ್ ವಿತ್ ಮೀ CH3 minus, NH2 minus, OH minus, F minus. ಇವುಗಳಲ್ಲಿ ಯಾವುದು ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಅಂತ ಕೇಳ್ತಾರೆ. ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಯಾವುದು? ಈಗ ಹೇಗೆ ಹೇಳುದನ್ನು ಸ್ಟ್ರಾಂಗ್ ಬೇಸ್ ಯಾವುದು ಅಂತ ಹೇಗೆ ಹೇಳುದು? ವಾಟ್ ಈಸ್ ಎ ಬೇಸ್? ಬೇಸ್ ಇಸ್, ಇದು ಜೆ ಮೇಲೆ ಕೇಳುವಂತ ಕ್ವೆಶ್ಚನ್, ನೀಟಿಗೆ ಕೇಳುವಂತ ಕ್ವೆಶ್ಚನ್. ಬೇಸ್ ಅಂದ್ರೆ ಏನು? ಬೇಸ್ is a substance which accept H plus. Stronger it accept the H plus, stronger will be the base. ಆದ್ರಿಂದ CH3 minus H plus ಅನ್ನು ಸ್ಟ್ರಾಂಗ್ ಆಗಿ accept ಮಾಡ್ತದ, F minus H plus ಅನ್ನು ಸ್ಟ್ರಾಂಗ್ ಮಾಡಿ accept ಮಾಡ್ತದ ಅಂತ ಹೇಳ್ಬೇಕು. Who will accept the H plus stronger? CH3 minus one side ಅಲ್ಲಿ ಉಂಟು, or F minus ಇನ್ನೊಂದು ಸೈಡ್ ಅಲ್ಲಿ ಉಂಟು. To understand that, find out this negative charge, how it is distributed, ಹೇಗೆ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದೆ, ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಹೇಗೆ ಉಂಟು ಅಂತ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ನಮ್ಮಲ್ಲಿ ಈಗ ಕಾರ್ಬನ್ ಉಂಟು, ಬ್ಲೂ ಕಲರ್ಲಿ ಬರ್ತೇನೆ. ನೈಟ್ರೋಜನ್ ಉಂಟು, ಸ್ವಲ್ಪ ಲೈಟ್ ಬೋಲ್ ಬರ್ತೇನೆ. ಸ್ವಲ್ಪ ಗ್ರೀನಿಶ್ ಕಲರಲ್ಲಿ ಆಕ್ಸಿಜನ್ ಬರ್ತೇನೆ. ದೆನ್ ಇಟ್ ಈಸ್ ಮೇ ಬಿ ದ ಗ್ರೇ ಕಲರಲ್ಲಿ ಫ್ಲೋರೈಡ್ ಬರ್ತೇನೆ, ಫ್ಲೋರಿನ್ ಆಟಮ್ ಬರ್ತೇನೆ. ಸೊ ಐ ರಿಟರ್ನ್ ಆಕ್ಸಿಜನ್, ನೈಟ್ರೋಜನ್, ಕಾರ್ಬನ್, ನೈಟ್ರೋಜನ್, ಆಕ್ಸಿಜನ್, ಫ್ಲೋರಿನ್. ಈಗ ಕಾರ್ಬನ್ ನ ಮೇಲೆ 3 ಹೈಡ್ರೋಜನ್ಗಳಿದ್ದಾವೆ. ಸೊ 3 ಹೈಡ್ರೋಜನ್, ಒಂದು ಹೈಡ್ರೋಜನ್, ಸೆಕೆಂಡ್ ಹೈಡ್ರೋಜನ್, 3 ಹೈಡ್ರೋಜನ್ಗಳಿದ್ದಾವೆ. ಆದ್ರಿಂದ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಉಳಿದ ಜಾಗದಲ್ಲಿ ಸ್ಪ್ರೆಡ್ ಆಗಿ ಉಂಟು. ಸೊ ಇದು ನೈಟ್ರೋಜನ್, ಕಾರ್ಬನ್ ಆಟಮ್ ಮೇಲೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್, ರೆಡ್ ಬರ್ತದನ್ನು ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಸ್ಪ್ರೆಡ್ ಆಗಿ ಉಂಟು. ಗಾಟ್ ದ ಐಡಿಯಾ? ಈಗ NH2 ಮೈನಸ್ ಅಲ್ಲಿ ನೋಡಿ, ನೈಟ್ರೋಜನ್ ನ ಮೇಲೆ 2 ಹೈಡ್ರೋಜನ್ಗಳು ಉಂಟು. ಆದ್ರಿಂದ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಸ್ವಲ್ಪ ಹೆಚ್ಚು ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿ ಉಂಟು. ಈಗ ಇನ್ನು ಸಹ ಮುಂದೆ ಹೋದ್ರೆ ಆಕ್ಸಿಜನ್ ನ ಮೇಲೆ 1 ಹೈಡ್ರೋಜನ್ ಉಂಟು. ಹಾಗಾದ್ರೆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಮತ್ತು ಸಹ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿ ಉಂಟು. ಆ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಫ್ಲೋರೈಡ್ ಮೇಲೆ ಹೈಡ್ರೋಜನೇ ಇಲ್ಲ. ಸೊ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಫುಲ್ ಆಗಿ ಸರೌಂಡ್ ಆಗಿ ಉಂಟು. ಈಗ ನನ್ನ ಪ್ರಶ್ನೆ ಅಂದ್ರೆ, H ಪ್ಲಸ್ ಅಯಾನ್ ಹೋಗಿ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಅನ್ನು ಹುಡುಕ್ಲಿಕ್ಕೆ ಹೋಗ್ತಾ ಉಂಟು. ಹುಡುಕುವಾಗ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಸುಲಭದಲ್ಲಿ ಎಲ್ಲಿ ಸಿಗ್ತದೆ? ಕಾರ್ಬನ್ನ ಮೇಲೆಯ ಫ್ಲೋರಿನ್ನ ಮೇಲೆಯ? ಕಾರ್ಬನ್ ಮೇಲೆ ಒಂದೇ ಕಡೆಯಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಟ್ ಆಗಿ ಉಂಟು, ಫ್ಲೋರೈಡ್ ಮೇಲೆ ಫುಲ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿ ಉಂಟು. ಅಂದ್ರೆ ನಿಮ್ಗೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೇನೆ. ನೀವೊಂದು ಒಬ್ರು ಇದ್ದೀರಾ ನಿಮ್ಮ ಕಾಲೇಜಲ್ಲಿ ಯಾರೋ ನಿಮ್ಮನ್ನು ಹುಡುಕಿಕೊಂಡು ಬರ್ತಾ ಇದ್ದಾರೆ. ಆಗ ಆ ಹುಡುಕಿಕೊಂಡು ಬರುವವರಿಗೆ ಯಾರು ಹುಡುಕಿಕೊಂಡು ಬರೋದು H+ ಆಗೋಯ್ತು. ಹುಡುಕಿಕೊಂಡು ಬರುವವರಿಗೆ ನೀವು ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಇದ್ರೆ ನಿಮ್ಮನ್ನು ಹುಡುಕ್ಲಿಕ್ಕೆ ಸುಲಭವ, ಅಥವಾ ನೀವು ಒಂದು ವೇಳೆ ಒಂದು ದೊಡ್ಡ ಮೈದಾನದಲ್ಲಿ ಪ್ಲೇ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ ದೊಡ್ಡ ಏರಿಯಾದಲ್ಲಿ ಎಲ್ಲೋ ಒಂದು ಕಡೆ ಇದ್ದೀರಾ, ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದ್ದೀರಾ, ಅಲ್ಲೇ ಹುಡುಕ್ಲಿಕ್ಕೆ ಕಷ್ಟ ಸುಲಭವ ನಿಮ್ಗೆ? ಅಥವಾ ನಿಮಗೆ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ಒಂದು ಸಣ್ಣ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ನೀವಿದ್ದೀರಾ, ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ ಪ್ಲೇಸ್ ಅಲ್ಲಿ ಇದ್ದೀರಾ, ಅಲ್ಲಿ ಹುಡುಕ್ಲಿಕ್ಕೆ ಕಷ್ಟ ಸುಲಭವ? ಆಬ್ವಿಯಸ್ಲಿ ಡಿಫಿಕಲ್ಟಿ ವೆನ್ ಯು ಆರ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್. ಒಂದು ಸ್ಕೂಲ್ ಡೇ ದಿವಸ ಅಥವಾ ಸ್ಪೋರ್ಟ್ಸ್ ಡೇ ದಿವಸ ನೀವು ಒಂದು ವೇಳೆ ಗ್ರೌಂಡ್ ಅಲ್ಲಿ ಇದ್ರೆ ನಿಮ್ಮನ್ನು ಹುಡುಕೊಳ್ಳಿಕ್ಕೆ ಹೇಗೆ ಕಷ್ಟ ಸುಲಭ? ಇಂಪಾಸಿಬಲ್ ಪ್ರಾಕ್ಟಿಕಲ್. Whereas if you are there in the classroom with the person who came in search of you, ಸುಲಭದಲ್ಲಿ ನಿಮಗೆ ಸಿಗ್ತಾರೆ, ನಿಮ್ಮನ್ನು ಐಡೆಂಟಿಫೈ ಮಾಡ್ಲಿಕ್ಕೆ ಬರ್ತಾರೆ. Therefore, when the charge is present in a small area, concentrated area, reaching is easier. So CH3- accept the H+ readily. Fluoride ion cannot accept it easily. So CH3- is a strong base, fluoride ion is a weak base. Therefore, basic nature should be maximum for fluoride CH3 and minimum for F-. The moment you could prove that CH3- is the strongest base, you can immediately tell acidic strength of their conjugate acid is it opposite. For example, methane therefore is a weakest acid and HF is the strongest base. Yakende fluoride is the weakest acid. I made a mistake. Fluoride is the weakest base. So I spoke about the base. Fluoride is weakest. CH3- is the strongest base. So if they are conjugate acid, CH4 is the weakest acid and HF is the strongest acid. So hope you understood. Therefore, the moment you know how exactly you can tell the acidic strength, you can automatically tell their conjugate acid or base their strength. So the conclusion is, stronger the acid, weaker will be its conjugate base. And therefore, this acidic strength telling even should be possible to you. For example, the basic nature. Therefore, same thing what we spoke, you can extend it further. You can extend it further in telling that if CH3 is a stronger base than NH2 than OH- than F-, then just I can see some. Can you please repeat once again the one which I spoke just now? Okay. Therefore, I was referring to here that if the charge, negative charge, present on an atom, if it is concentrated, H+ can approach it readily. So in CH3-, because of the presence of 3 hydrogen atoms, the charge is concentrated. So H+ can attack it readily. If H+ can attack readily, CH3- is a strong base. NH2- little weaker than that. OH- still weaker than that. F- is weakest. Opposite will be the strength of the conjugate acid. If the CH3- is the strongest base, its conjugate acid CH4 is the weakest acid. F- is the weakest base, its conjugate acid HF is the strongest acid. Hope I was clear. Therefore, you can extend this idea further telling that I was talking about CH3 minus, NH2 minus, OH minus, and F minus. You can further say that come down in the periodic table below nitrogen, there is phosphorus, pH2 minus, SH minus, Cl minus. So pH2 minus is stronger than SH minus than Cl minus. So is the remaining. All the places you can tell pH2 minus is stronger than SH minus than Cl minus. A arsenic hydride is a stronger base than selenium hydride, which is stronger base than Br minus. So is antimony and tellurium and so on. And they are conjugate acids. Therefore, look at the moment I understand the concept of stronger the acid, weaker the conjugate base, you can talk about the bases, also they are conjugate acids. So everywhere you can tell the basic stand, this is stronger, this is stronger, this is stronger, this is stronger, and so on. Therefore, I can tell this is stronger, this is stronger, this is stronger, this is stronger. Therefore, it is. Now, quickly tell, if you have understood me well, down the group, what should happen? Number of hydrogen is same. Down the group, basic strength should increase or decrease. You know, down the group, the atomic size of the central atom increases. So this is an oxygen atom, smaller atom. This is sulfur, a bigger atom. This is selenium, still a bigger atom. And tellurium, much bigger than that. And they contain one hydrogen here. All contain one hydrogen. And therefore all contain here one hydrogen. Now tell, where should be the negative charge? Negative charge is distributed in a small place in oxygen, bigger place in the case of sulfur, still bigger place. Can you apply the same logic what we spoke earlier? That bigger the distribution of the charge, higher the distribution of the charge, weaker is the base. So charge should be, therefore, down the group, the basic nature of the as bases, basic nature decreases. Why? Charge is distributed. Proton will find it difficult to approach. So this also should be possible. This is the advantage of Bronsted-Lowry theory we can apply. Therefore, basic nature decreases and further decreases even down the group. This idea of why down the group, because of the central atom size increase will occur there. Now, even oxidation state of the central atom on oxy acid will give you an idea. For example, higher the central atom oxidation state, stronger the acid. So HClO4 is a stronger acid than HClO3, then HClO2 and so on. Why like that? Because if you are talking about HClO, this is nothing but chlorine with the OH group. What is HClO2? This is chlorine with the OH group with the electron withdrawing oxygen atom on it. HClO3 means what? Chlorine with the OH group and 2 electron withdrawing group on it. What is HClO4 means? Chlorine with the OH group with the 3 electron withdrawing groups on it. Now tell me, higher the electron withdrawing groups, stronger is the acid. Because the moment, what is this? The moment you remove this H plus, the moment you say, I want to remove this H plus, what am I remaining with? I remain with the H plus ion. If at all I remain with the H plus ion, then if I remove this H plus ion, I have this minus charge. If I remove this H plus ion, I have this minus charge. Remove this H plus ion, I have this minus charge. Remove this H plus ion, I have this minus charge. This negative charge, when it is present, the oxygen atom pull the negative charge. And you know, more the electron is pulled out away from the O minus, stronger will be the acid. Because if the conjugate base is stronger or stable, not stronger, stable, acid is stronger. So if at all HClO gives you this H plus ion, gives you this, if you prove that if this gives you this is most stable, this is most stable. So H plus will come out easily. Why this is most stable? Because this negative charge can be withdrawn to this. So one oxygen can withdraw, second oxygen can withdraw, three oxygen can withdraw. This negative charge is like tension. If this oxygen atom pulls the tension out, this oxygen atom pulls the tension out, three oxygen atom pulling the tension out, making this is more stable. Higher the stability of the conjugate base, stronger is the acid. This is the weakest conjugate base. Therefore, ClO minus, therefore there are nobody to stabilize it. There are no oxygen atom to stabilize it. Therefore, HClO is the weakest acid and HClO, that you can tell based on oxidation number. Higher the oxidation number of the central atom, more will be its, higher the oxidation state of the central atom, more will be its acidic nature. Therefore, you can take a few examples there, like all these acids, where oxidation state of the central atom is more is the acid. Therefore, the HClO4 is stronger. Therefore, first acid in every places which I have written is a stronger acid, next acid is a weaker acid. So, these are the questions generally they ask in the examination. For the NEET, they may ask you among HClO4, HClO3, HClO2, ClO4, which one is a stronger acid? HClO4. Why? Higher the oxidation state. One more, give reason in case if the reasons are listed. More is the stability of the conjugate base. More the stability of the conjugate base. If the conjugate base is more stable, it is formed faster. If it is formed faster, it gives H plus faster. If it gives H plus faster, stronger acid. Same way you can. Now this another concept, you have to understand it well. This once again possible for your JEE main question, that concept of leveling effect. Iga, if you identify hydrochloric acid, iga water ge haki, it gives you H plus readily, strong acid. Acidic acid and water again. ಅಷ್ಟು ಸುಲಭದಲ್ಲಿ ಕೊಡುವುದಿಲ್ಲ H plus ಆಗಿ. So weak acid. So in water, hydrochloric acid is a strong acid and acetic acid is a weak acid. Now I am telling why acetic acid is a weak acid. Because acetic acid was ready to give, acetic acid is present here. Okay, I write once again. Oh my God. Acetic acid is present here, which is giving acetate ions and H3O plus. So acetic acid reacting with water, it gave H plus. Acetic acid gave H plus to water. Now, instead of telling like that, tell water took H plus from acetic acid. Water was not readily taking. Water was not happy to take H plus. So acetic acid did not give it fast. So instead of telling acetic acid did not give it fast, you say water was not capable of taking it fast. Therefore, acetic acid behaves weak. Now you replace this water with something else who is capable of taking H plus stronger than water. Who is that? Ammonia. So don't add acetic acid to water. Instead, add acetic acid to ammonia. Now, what ammonia does? Ammonia is a very powerful acceptor of proton. Readily takes H plus. If ammonia readily takes H plus, acetic acid readily gives. Therefore, in ammonia, acetic acid is a strong acid. HCl, water only it was giving readily. In ammonia, it should give no. Therefore, if you have ammonia as a solvent, acetic acid as well as hydrochloric acid give H plus readily in ammonia. So, ammonia is said to be a leveling solvent for hydrochloric acid and acetic acid. And water is a differentiating solvent for acetic acid and hydrochloric acid. So this is a possible question for your JEE main, wherein how to make acetic acid stronger? Change the solvent. Which one? Add a basic solvent. Therefore, in the basic solvent, acid becomes stronger. In acidic solvent, acid becomes weaker. Therefore, ammonia is said to be a leveling solvent, whereas water is said to be a differentiating solvent as far as the acidic basic nature is concerned. A few more examples you can give. ಈಗ hydrochloric acid and sulfuric acid. Both acids will, hydrochloric acid and sulfuric acid, both ionize readily in water. Hydrochloric acid ಇರ್ಬೋದು, hydrobromic acid ಇರ್ಬೋದು, hydroiodic acid. Hydrochloric acid, hydrobromic acid. Both ionize completely in water. I want one to ionize, one not to ionize. Then what you do? You put somebody who is not taking H plus readily like water. Who is that? Maybe acetic acid. Acetic acid is a solvent. Therefore, if you use acetic, therefore, what do you mean by acetic acid solvent? In the laboratory, when you open the tap, if water flows in the beaker, put hydrochloric acid, hydrobromic acid, both will have same acidic nature. Both are strong acid. If open the tap, if acetic acid was to flow, now you add hydrochloric acid to it, it doesn't ionize readily. Hydrobromic completely ionizes. Why? Because hydrobromic chloric acid is not happily giving H plus. Acetic acid says, I do not want it. Acetic acid is not a good acceptor of proton because it's acidic nature. Therefore, if I put an acidic medium, two acids both who are stronger earlier, one of them behaves strong, one of them weak. Therefore, acetic acid is a differentiating solvent for hydrochloric acid, hydrobromic acid, where hydrobromic acid is stronger, whereas water is a leveling solvent for both hydrochloric acid and hydrobromic acid. So these are the acids, acid base that is differentiating I was talking about. With that, I think we have come to the end of our discussion today, wherein we spoke the relative acid-base strength. Like that, whichever concept which you take it up, maybe the Lewis acid-base theory, maybe the Lux flood theory which you talk about, which talks about oxide ion, donor oxide ion receptor. Everywhere we can go and find out good number of questions which will come for different levels of competitive examination. Once again, I thank you all for this patient listening. Thank you for the sharing this, giving me opportunity to share my little thoughts, and for these interactions here and there in between where you asked a few questions. Hope I was able to clear your doubts then and there. Thank you so much for this wonderful opportunity once again.
Thank you, sir.
Yeah, yes, wait.
Sir, Umesh, sir?
Yeah.
1 minute, sir. Sir, Yogesh ಅವರು ಯಾವ ಪಾರ್ಟ್ ಅಂತ ಗೊತ್ತಿಲ್ಲ. ಸರ್, can you please repeat once again ಅಂತ ಕೇಳಿದ್ದಾರೆ.
ನಾನು repeat ಮಾಡಿದೆ sir ಅಲ್ಲಿ. I repeated.
Oh, sorry, I didn't see.
Yeah, just he wanted about that CI3 minus ಹೇಳುವಾಗ
Yes, sir.
he wanted that some clarity. I gave a few more examples in between and I saw that chat box and I explained to him. That's what I nice to interact with them also.
Thank you, sir. Chat box ಅಲ್ಲಿ ಯಾವುದೇ questions ಇಲ್ಲ.
Initial one question was there. I just responded immediately there.
Okay, sir. I sent through mail, sir.
Thank you so much once again. Thank you so much.
So thank you, sir. Today you are giving a very informative talk on acid base chemistry. So ಮಕ್ಕಳಿಗೆ ಭಾರಿ ಸರಳವಾಗಿ ನೀಟ್ ಮತ್ತೆ JEE CET ಎಕ್ಸಾಮ್ಗಳಿಗೆ ಆಸಿಡ್ ಬೇಸ್ ರಸಾಯನಶಾಸ್ತ್ರದಲ್ಲಿ ಯಾವ ರೀತಿ ಕ್ವಶನ್ಸ್ ಬರಬಹುದು ಅನ್ನೋದು ಕೂಡ ನೀವು ವ್ಯತಿರಿಕ್ತವಾಗಿ ಭಾರಿ ಸರಳವಾಗಿ ಕನ್ನಡ ಮತ್ತು ಇಂಗ್ಲಿಷ್ ಎರಡರಲ್ಲೂ ಕೂಡ ತಿಳಿಸ್ಕೊಟ್ಟಿದ್ದೀರಿ ಸರ್. So on behalf of KST and myself, I thank you, sir.
Yeah, it's a wonderful opportunity. Thank you once again. If there is any clarification, let them please, and I will be happy to clear their doubts in that.
Yes, sir. I sent through mail, sir.
Yes, thank you so much.
Okay, once again, I thank you, sir.
Yeah, yes.
ಸೊ ಇದೇ ರೀತಿ ನಮ್ಮ ಈ ಒಂದು ಕಾರ್ಯಕ್ರಮವನ್ನು ಆಯೋಜನೆ ಮಾಡಿ ನಮಗೆ ಪ್ರತಿದಿನನೂ ಆಯೋಜಿಸ್ತಾ ಬಂದಿರತಕ್ಕಂಥ ನಮ್ಮ ಅಕಾಡೆಮಿಯ ಮುಖ್ಯ ಕಾರ್ಯನಿರ್ವಹಣಾಧಿಕಾರಿಗಳಾದಂಥ ರಮೇಶ್ ಅವರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ಸರ್. ಸೊ ಇಂದಿನ ತರಗತಿಯಲ್ಲಿ ಹಾಜರಾಗಿದ್ದಂಥ ನನ್ನ ಎಲ್ಲ ವಿದ್ಯಾರ್ಥಿ ಮಿತ್ರರಿಗೂ ಕೂಡ ಧನ್ಯವಾದಗಳು ತಿಳಿಸುತ್ತಾ, ನಾಳೆನೂ ಕೂಡ ನಮ್ಮ ಹರಪ್ರಸಾದ್ ಸರ್ ಅವರು ಉಪನ್ಯಾಸ ನೀಡಲಿದ್ದು ಹೆಚ್ಚಿನ ಸಂಖ್ಯೆಯಲ್ಲಿ ವಿದ್ಯಾರ್ಥಿಗಳು ಹಾಜರಾಗಬೇಕೆಂದು ಮತ್ತೊಮ್ಮೆ ನಮ್ಮ ಅಕಾಡೆಮಿ ವತಿಯಿಂದ ತಿಳಿಸುತ್ತಿದ್ದೇವೆ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.
Thank you very much, sir.
Thank you.